Most people think the space industry is still mainly about government exploration missions and scientific discovery. But in reality, space is rapidly becoming a commercial infrastructure layer of the global economy. A new orbital economy is emerging, one built around communications, logistics, data, surveillance, and real-time planetary intelligence. This is what many now call the new space race. At its core, this trend is about the industrialization of Earth's orbit. For decades, space was dominated by governments and national agencies. But today, falling launch costs, reusable rockets, private investment, and satellite miniaturization are transforming orbit into a scalable commercial platform. And this transformation is beginning to reshape telecommunications, defense, logistics, climate monitoring, and global connectivity. To understand why this trend exists, you first need to understand the economic and technological forces driving it. One major driver is the dramatic reduction in launch costs. Reusable rocket systems are lowering the financial barrier to orbit by orders of magnitude, making frequent launches commercially viable for the first time in history. Another major shift is satellite miniaturization. Small sats and CubeSats are enabling mass-produced orbital constellations capable of delivering global coverage at far lower costs than traditional satellite systems. At the same time, global demand for connectivity continues to explode. Governments, businesses, logistics systems, and consumers increasingly require high-speed internet, real-time communication, and constant access to geospatial intelligence. And geopolitical competition is accelerating the race even further. Space has become a strategic high ground for national security, surveillance, communications, and military resilience. Today, orbital infrastructure is increasingly becoming a strategic layer of the global economy. To understand how this ecosystem works, you need to break it into 5 major pillars. The first pillar is launch and orbital access. Reusable rocket systems provide the transportation layer required to deploy satellites, cargo, and future infrastructure into orbit. The second pillar is space infrastructure. This includes orbital servicing systems, satellite refueling, commercial space habitats, and the operational platforms needed for long-term activity in space. The third pillar is satellite connectivity. Large low-Earth orbit constellations are creating global high-speed internet networks capable of reaching remote regions worldwide. The fourth pillar is orbital data and intelligence. High-resolution Earth imaging systems now provide real-time climate monitoring, agricultural analysis, military intelligence, and geospatial tracking. And the fifth pillar is space security and awareness. As orbit becomes increasingly crowded, new systems are required to track debris, monitor orbital traffic, and protect critical infrastructure from collisions or interference. Behind the scenes, operating the orbital economy requires highly sophisticated coordination systems. Companies manage reusable launch schedules, refurbish rocket boosters for rapid reuse, maintain satellite constellations, process enormous volumes of orbital data, and coordinate global ground station networks connecting space infrastructure to terrestrial systems. At the center of this ecosystem is a highly integrated value chain. It begins with launch systems, the physical act of reaching orbit. Then comes satellite deployment and constellation management. Next is network operations, maintaining global communications between orbital and terrestrial infrastructure. After that comes data processing, transforming raw orbital data into actionable intelligence. And finally, downstream services deliver connectivity, analytics, logistics, and intelligence directly to businesses, governments, and consumers. Now, who is actually buying this technology? Governments and defense agencies are investing heavily in secure communication systems, strategic surveillance infrastructure, and orbital monitoring capabilities. Commercial enterprises increasingly rely on satellite systems for logistics coordination, navigation, agriculture, aviation, shipping, and global internet access. And environmental organizations and research institutions use orbital intelligence to monitor climate systems, planetary health, and global resource management. Now let's talk about monetization. One major revenue source is launch contracts, transporting commercial and government payloads into orbit for multi-million-dollar fees. Another fast-growing business model is satellite connectivity subscriptions. Companies operating orbital internet constellations generate recurring revenue from global communication services. Data and analytics licensing is also becoming increasingly important. Orbital imaging companies sell high-resolution intelligence, mapping systems, and geospatial analysis to governments and corporations. And entirely new revenue models are emerging around orbital servicing, satellite refueling, debris removal, and long-term infrastructure maintenance in space. Several major companies are emerging as structural leaders in this ecosystem. SpaceX dominates reusable launch systems and orbital logistics infrastructure. Northrop Grumman remains a major provider of advanced space systems and strategic aerospace infrastructure. Planet Labs is building one of the world's leading Earth imaging and geospatial intelligence platforms. Starlink is rapidly becoming the largest low-Earth orbit internet constellation globally. And companies like Leo Labs and Lockheed Martin are developing critical orbital security and space awareness systems. Now let's talk about where this trend is heading next. Heavy-lift reusable rockets are enabling larger orbital infrastructure projects than ever before. Satellite manufacturing is shifting from bespoke engineering toward high-volume industrial production. Commercial space stations may eventually replace government-operated orbital platforms. And defense spending on resilient space infrastructure continues to accelerate globally. As this trend expands, industries most exposed include telecommunications, logistics, insurance, aerospace, defense, and global communications infrastructure. But despite the enormous opportunity, the orbital economy also faces major risks. One major challenge is orbital crowding. Thousands of satellites and debris particles increase the risk of cascading collisions that could eventually make certain orbital lanes unusable. Another issue is regulatory fragmentation. There is still no universal global framework governing orbital traffic management, resource rights, or long-term space operations. And like many infrastructure-heavy industries, space remains extremely capital-intensive, requiring enormous upfront investment before achieving profitability. Geopolitical conflict also creates growing risks for critical commercial space assets during periods of international tension. At the end of the day, the new space race is not simply about exploration. It is about building the next strategic infrastructure layer of the global economy above the Earth itself. And as communications, logistics, intelligence, and orbital infrastructure continue to expand, space may become one of the most important operational environments of the 21st century. If you want to understand markets, you have to understand this system. Subscribe to NAVIXA for clear, structured market insights.